Discovery, go at throttle up.
Okay, welcome to the Spacex Falcon 9 NROL-167 launch coverage. It is October 24th, 2024, and we are looking at a launch here in about 10 minutes. Actually, less than 10 minutes. I'm EJ, your host. This is the Eric Johnson Space Administration, and I will dispense with the pleasantries, Commander. Let's jump right in.
The fairings are made of carbon.
What's the payload? Oh, it's the And satellite and payload.
Which creates the space to accommodate an average-sized fire truck. The fairing
A fire
made up of
truck.
2 halves will separate and jettison away from the vehicle, exposing the payload once Falcon 9 reaches space. Now, continuing down the vehicle, we have the second stage.
All right.
The second stage is powered
Discovery, go at
So,
throttle up.
engine,
what-
or what we call the MVAC engine.
What do we have? This is the
optimized
L-167
for
mission.
space.
It's launching on
Separation
booster 1063. This will be its 21st flight. Here, 49-day turnaround. This is the 102nd SpaceX mission of 2024 and the 100th Falcon 9 mission.
Some good call-outs there. That is the system that decouples the 2 stages during stage separation. Now below that is the first stage, which is powered by 9 Merlin engines. These 9 Merlin engines provide the initial thrust to lift Falcon 9 off the ground through the lower, thicker parts of the atmosphere. There are 8 engines arranged around one center engine and collectively held in place by a structure called the octaweb. Each of these Merlin 1D engines delivers about 109. After stage separation, stage 1, which we also call the booster, will return back to Earth for recovery and reuse on a future mission, which using a combination of Merlin sea-level engines and the 4 titanium grid fins located near the top of the booster, which will guide the vehicle during its re-entry and landing.
No
The
comment,
Falcon 9
Tessa.
first stage is also equipped with 4 landing legs that deploy just before landing and allow for vertical touchdown on a drone ship or landing pad. For today's
Okay, Norma,
mission,
thank you.
we'll be attempting to land this booster on our drone ship, Of Course I Still Love You, which is currently stationed in the Pacific Ocean, which you can see there on your screen. Both the weather and the vehicle,
Falcon 9 tanks are
No,
pressing
Dean.
for strong back retract.
again, some good call-outs there. Both the weather
BA,
and
what's
the
up, man?
vehicle continue to look good for today's launch out of Vandenberg Space Force Base in California.
Discovery, go at throttle up.
Fine, what's going on? 50
And
months.
as
Halfway
you
to the
heard
century
that
mark.
call-out, we are
Yeah. 5 p.m.
preparing
Jazos.
for strong back retract.
Strong back
That
retract.
is also known as the transporter rector, TE.
There you go, bio.
The
Strong back
transporter,
retract has started.
good call out there. The TE is now going to begin to retract away from the vehicle. That's that large trusted structure.
So, I always like this shot of the Vandenberg TE because if you can really get a good sense of scale here if you look at the ladder. The ladder that looks like it's for children. Right there. That shows you how big Falcon 9 actually is. You don't think it's as big as it actually is, but you see the ladder and the railings right there, and you're like, huh, okay. What is this, a ladder for ants?
It's very slow and slight, but it's just enough to help clear
Ads?
the way for Falcon 9.
Discovery, go at throttle
Yeah,
up.
okay. All right, we'll run the ads so nobody gets pre-rolls or any ads during the launch. Be right back.
Now the first
Slub
stage
Man,
is connected
95
to a
month
launch mount
resub,
at the
thank
base
you.
Of the TE, but the TE is hinged and will retract away even further
All
in
good, dudes.
preparation for launch at T0.
The fairing looks a bit
The TE is
chunkier than
designed to
usual.
transport, raise, and
It's
support
just
Falcon
been
9
burned up a little
at the
bit
launch
because
pad,
it's been
and
reused.
It's also equipped with umbilicals or flexible lines that are used to route the vehicle's fluids, power, and telemetry from the ground systems to the rocket and payload until Falcon 9 switches to
TE's
internal
in
power.
the 87-degree
clears the
retracted
pad.
position. Hello, Kevin. Wie geht's?
And you can see on your screen that umbilical connecting from the TE to
That's
the
payload
vehicle.
fairing,
At
payload
liftoff,
fairing
that
HVAC.
will disconnect.
Stage 1 locks loaded.
And it's moving around a little bit more than it usually
And good
does.
call out there. Stage 1 LOX load is now complete. Stage 2.
Yeah, of course they
LOX
do,
load
Tech.
will complete at the T
It's not as much as you might think, dude. So the fairings do encounter re-entry heating, you could see, but it's not as much as like a capsule. Now, why is that, dude? So, okay, say we're at the top of the Empire State Building, and I have a 1 pound rock, and then I have a piece of paper, right? You drop the rock, right? It's going right down there. It might move around a little bit in the wind, right? But it's just straight gravity, right? And then you take the piece of paper and you let the piece of paper go. What happens to the paper? It's just going to... That paper is most likely going to get to the surface relatively intact, provided it doesn't hit anything, right? The rock, though, it's going to hit the ground going pretty fast, right? That's what the fairings are versus like a first stage. The fairings are a very big voluminous piece of spaceflight equipment, but for the volume, they're super freaking light. They're carbon fiber and aluminum, basically, like kind of sandwiched together like an Oreo cookie, right? So they do experience some reentry heating, but it's actually not a lot for that same reason why that piece of paper can make it all the way down from, like, if you dropped it off the top of the Empire State Building, paper will just weeble wobble all the way down. That's what the fairings basically do. Yeah, they're very light. And because they have a very low ballistic coefficient and a low ballistic coefficient, high coefficient of drag, low mass, they just sail all the way down. And then they drop. The interesting thing is they drop a parafoil, so they actually kind of hang glide back to the recovery ships and land right next to them. SpaceX was trying a long time ago to land them on a netted ship, but they figured out that waterproofing the fairings is actually better, and it just basically glides and lands like a seaplane right next to the recovery ship. Super cool stuff, actually. Okay, Falcon 9 is in startup.
The countdown, just waiting for the final go from the launch director.
SpaceX
There
launch
you
director, go for
Rocket.
launch.
Thank you. Yeah.
And great news, we are go for launch. Let's listen and watch as Falcon 9 takes the NRO payload into space.
Do I know how fast the fairing is going on reentry? Probably like 4,000 or 5,000 miles an hour, something like that. No, hypersonic. I've never seen it. 20 seconds. Okay. This is the Falcon 9 carrying the NROL-167 payload, or the payload
10,
that's
9, 8, 7, 6, 5, 4, 3, 2.
sound suppressor is on.
1. Ignition.
Engine ignition.
And launch. Go, SpaceX.
Okay, starting off with a early afternoon National Reconnaissance Office uphill ride into space on Falcon 9.
Stage 1 propulsion is nominal.
Got the good call for propulsion here, 20 seconds into the flight. Everything looking good. In the next 20 seconds, you should hear the call for power and telemetry. This is launching out of Vandenberg.
T plus 35 seconds into launch, and
Vandenberg
Falcon
Space
9
Force
has
Base in
successfully
California.
lifted off from
Lompoc,
Space Launch
California.
Complex 4E at Vandenberg Space Force Base in California.
See?
Nominal power and telemetry.
Okay.
Good calls on ascent. Coming up next, the vehicle will be passing through Max Q in a few seconds
Wolf,
here.
it's
This is
pretty
the
awesome.
point of
Vehicle supersonic.
this is the point where the vehicle experiences the greatest amount of aerodynamic pressure.
Interesting. There's Slick 3 right there. That's Slick 3 East and
Max
Slick
Q.
3 West. That's Vulcan's launch
Great
pad.
call out there. And now the vehicle has passed through that highest amount of structural load on the vehicle. Now coming up next, we will have a few events happening very quickly in succession. That'll be MECO, stage separation, and SES-1.
They are
MECO
pretty
is
slick.
main engine cutoff, and that's where all 9 of those Merlin 1D engines that you see burning bright
Impact
on the
chill has
screen.
started.
This is a not
Those 9 engines
Whoa.
will shut down. That helps slow the
Nice.
vehicle down in preparation for stage separation. Stage separation is where the first stage
This
and
is a
second
low
stage
inclination
separate,
insertion for
and the first
Vandenberg.
stage will continue to make its
Look at
way
that.
back down to Earth as the second stage continues with the payload to take it to its targeted drop-off
Rocket.
orbit.
This doesn't look like SSO to me. I noticed the roll program. They're not. This is not aiming for a 97-degree inclined.
And we are coming up on MECO stage separation and SES-1. SES-1 is second stage engine startup 1.
Unless you
Or
can
we'll
get
light that MVAC
SSO from an
engine on the
87
second
or an
stage.
88-degree inclined orbit, maybe. Look at that.
And as a reminder, we will not have any views of stage 2 or the payload at the request of our customer.
Main engine cut off.
There's MECO, stage separation.
Stage separation confirmed.
And back ignition.
Interesting.
Beautiful views. We had
Good ignition.
MECO, stage separation, as well as the ignition of the second stage engine. And now that first stage vehicle is making its
Look
way
at the
back
track,
down
Rocket.
to Earth.
Look at
and
the channel islands.
great view there with the grid fins deploying.
Yeah, no short nozzle either. First stage is coasting here. There's the Channel Islands. That's beautiful Southern California.
And you can see that the telemetry of stage 1, it has not yet reached its apogee, but once it does, it will begin to make its way back
That's
down
not,
to
that's
Earth
not
for-
sun-synchronous.
Separation confirmed.
Good call for fairing
for
separation.
landing, and good call out there that we had confirmation of fairing separation. We will be attempting to retrieve the fairing halves today once they fall back down to Earth with our recovery vessel Go Beyond in the Pacific Ocean.
Chris, I'll
Today's
explain more
fairings
about bearings in a
Are
second, okay?
flying for their 16th
Bear with me
and
here. I wanna see
7th
something.
times today.
They might be using the trajectory to hide the orbit.
And these views are so great.
I don't think that's a
You're
thing.
looking at a view from the
Oh,
first
did you
stage
see that
vehicle,
nitrogen get shot off that way?
and relative to Earth, it looks very slow and calm, but the vehicle is moving very quickly. You can see the speed in the bottom left-hand corner of your screen there.
That's on purpose,
And you can
Jake. It's
see
a
that the
National Reconnaissance
altitude
Office
has
payload.
stopped increasing.
Booster
We've
has
just
hit
about
apogee.
reached apogee, and now the vehicle should begin to make its way back down to Earth. Again,
No doubt, boy.
attempting our landing today
year.
on,
Thanks,
of
buddy.
course, I Still Love You, our drone ship in the Pacific Ocean.
It's a 70-degree inclination. That's what I'm saying. That's a low inclination for Vandenberg. Where's the miles per hour speed? This is America. 7,200 kilometers an hour is like 5,000 miles an hour. Somewhere around there.
Now we're just about a minute away from the next event for the first stage. That will be the entry burn. The entry burn is where we will reignite 3 of those Merlin M1D engines. This helps slow the vehicle down as it's re-entering the Earth's atmosphere.
Metric is better than
And
freedom.
that burn
Jesus.
should last about 20 seconds long for this
Put units at
mission
the end
today.
of that statement, and then I'll understand what you're saying. Otherwise, you should probably take that
And
one
some
back.
cool views here. This is from the first stage looking forward towards the top of the vehicle. And this is inside of the inner stage section of
That's right, Space
Falcon
Flight.
9.
Yeah, Phil.
Just
they've
under
definitely
30
done
seconds
that.
away from that entry burn.
Okay, time for supersonic retro propulsion.
Such great views here today.
Yeah, there
Again,
you go.
we are coming up on the
You're
entry
still wrong,
burn
but it's all right.
for the first stage vehicle. You can see the altitude decreasing, and we'll reignite
Carolux, that'd
those
be pretty cool.
engines to help slow the vehicle down even more.
Stage 1 entry burn
Here's
started.
the entry burn, dudes. Falcon 9's going to fire its engines to make sure that the re-entry heating gets pushed away.
And good call out there, and you can visually see
Basically
that
having
engines
the
have
engine exhaust
ignited.
become the heat shield.
Again, this burn will last about 20
pretty cool.
seconds.
Stage 1 entry burn shut down.
Here we go.
And good call out there, as well as visually
grid
seeing
fins are
that
gonna
the
take over?
engines have shut down.
Wait, is that legal?
That
Can they do?
concludes
Wait,
the
that's
entry
illegal.
burn
It's
for
pretty
this
cool,
first
right?
stage's
That's
journey
why
back to
it's my favorite part. NASA came up with this idea for landing on Mars that you can use the engines to basically be your heat shield, particularly the hot gases coming out of the engine. Now, why is that? Well, think about it like this. The rocket engines are designed to deal with that hot gas. They wouldn't be a rocket engine if they weren't. Most of the booster is designed to deal with that heat. That heat is cooler than the heating that would be encountered from entry, descent, and landing on a planet with an atmosphere. So somebody at NASA came up with the idea of using supersonic retropropulsion to basically make the hot gases from the rocket envelop the vehicle, because it's flying business end first, in a thermal medium, a cooler thermal medium of gas, right? Because, once again, the rocket's designed to take the heat from the engines. It's not designed to take the heat from reentry. Reentry is way hotter. So you can use the gases coming out of the rocket engine to push the reentry heating away. That's exactly what that does. That's why that's so cool, because it uses the engine gas as the heat shield. Therefore, you don't need a passive thermal protection system on board, like tiles or whatever. Now, with that being said, There are some spots of Falcon 9 that still get really hot, and it does have some thermal protection. But the rocket engine is the best insurance against heat in this case. Here we go. Here we go for the landing.
Deploy.
We got to deploy. Hey! Oh,
Stage 1 landing confirmed.
a little bit of a hard landing, but we all right.
And great views there. Falcon 9 has touched down on, of course, I Still Love You. This was the 21st launch and landing for this booster. This landing marks SpaceX's 358th recovery of an orbital-class rocket, including the first stage landings for Falcon 9 and Falcon Heavy.
They make it look so easy,
Today's
dude.
mission
Stand
marks
back, shut down.
Today's mission marks SpaceX's 396th overall mission to date and 101st mission of
There's
2024.
there's the vent down.
Now,
No
as a
residual
reminder, we
fire.
will not be showing any
Engine
Stage
purge.
2 or deployment
Looks good.
views at the request of our customer.
That's pretty ridiculous that this picture has gotten so crisp. I mean, look at. Hold on a second here. Look at this thing. Look at. I mean, this shot is still a little, but look at the shot on the drone ship. Dude, that's super crisp. There's nobody on board right now, a sailor, but there are recovery ships in the area that will get onto the ship. I wouldn't want to be on this thing when this thing lands. Thank you, Starlink. Yeah, dude. That's crisp. Very nice. Is that something else or what? So, guys, I actually noticed something here. Right, if we go back to here, we go over here, hit play, or just it's gonna tell me. Yeah, all right, cool. Right? No. All right, hold on. No, that's the Starship flight. That's not what I want. You know what? We can use this shot. Here. I want to point out there's another Falcon 9 sitting on the landing pad over there. So, if Falcon 9 is going to do a return to launch site at Vandenberg, it lands at the former Slick 4 West, so Space Launch Complex 4. Slick 4 at Vandenberg is a twin launch pad complex, or was a twin launch pad complex when it launched Titan missiles. There was one pad here and one pad over there. They're basically mirror images of each other, right? SpaceX bulldozed Slick 4 West, right, and made it a landing pad. And there's definitely a Falcon 9 just sitting over there on the crane with its landing legs folded up. I just wanted to point that out. There's definitely a Falcon 9 in another first stage just sitting over there. Just putting it out there. Looks a bit rusty. It's sooty from flying through its own exhaust, STX. Yeah. Pretty cool, huh? Just another Falcon 9 just sitting over there. Whatever. Just doing its thing. Another first stage. Pretty cool, huh? Also, Vandenberg is beautiful. If you ever get a chance to go out to Lompoc and see a launch, Southern California coast, man. It's pretty rad. There's a road that's just south of here called the Pacific Coast Highway. If you're not familiar with Southern California, everybody knows that road if you're from California, right? The Pacific Coast Highway is one of the best cruising roads in the world by a long shot. You just drive up and down it. You got the beach, got beautiful scenery. We drove up that during Route 154 with the 97, which is pretty cool. Highway 1, baby. Yep. It looks like that. It's pretty awesome. Yeah, there you go, Christian. Right. Okay, so Chris, you had a question. Yeah, fight fire with fire. I say it's not fighting fire with fire, it's fighting plasma with fire. Right? Because remember, reentry heating is plasma because it's ionized gas. Pretty crazy, right? So wouldn't the speed for returning the fairing be 9.8 meters a second per second? Well, that's the acceleration force that is imparted on the fairing from Earth's gravitational pull. The thing about the fairings is that that's an acceleration. So that is a force that's being applied to the vehicle, right? But the fairing does have a terminal velocity. The gravity pushing down on it is only going to make it speed up so much before basically the fairing causes so much drag that its terminal velocity is actually quite low comparatively. Like, once again, paper versus rock dropping from the top of a building, right? So gravity is not the only thing force being imparted on those fairings. Decelerative force is being imparted on them from drag. And because their mass to volume ratio is so ridiculously light, it's this big wide fairing that's super light for how big it is. Like I said, it's like dropping a piece of paper from a building. With the piece of paper, it's susceptible to drag, and even though gravity's pushing down on it, drag is pushing up on it. That's not the right way to say that, but you get the idea. The terminal velocity of the fairings is quite low. It's very low, and that stems from what's called a low ballistic coefficient. I mean, amongst other things. There's other ways to say it. But, yeah. M Australian have driven PCH. Yeah, there you go, Cookie. It's good stuff. Does that help, dude? Hey, Zoran, what's up? Help, I dropped a wrench on a Titan II missile. Run, Enzo. You want to run. When do you think SpaceX will demolish the current Starship launch tower and pad after the new one with the trench is complete? I don't think they will, Finn. I don't think they'll demolish that first tower. They might put a new OLM up there. On pad A eventually, but I don't think they will. I don't think they'll demolish that tower. Supercraft, what component is this? Vega P120C interstage? That's an SRB aft skirt. Most like, I don't know if it's from Vega or what, but... No, they did not, John. I think the OLM on Pad East is going to end up looking like Pad West. Probably. You need a rocket science class from EJ? Just watch this stream for a little while, dude. So, Supercraft, what you're looking at here is an SRB aft skirt. And those right there are thrust vector controllers. This SRB aft skirt attaches to the bottom of the SRB casing, and the throat from the SRB and the nozzle would be basically going through the center. These things would be attached to the nozzle. Could be from a P120C. It looks like it is. It's either a P120C from Vega or a P120C from Ariane 6. But I'm not sure if the P120Cs on Ariane 6 have thrust vector control. They might. Actually, they probably do. But standardizing components and all. Our launch is scheduled out enough that I could plan a vacation to see one. I want to see a Falcon Heavy launch. There's always a possibility of it scrubbing artificial. It's too wide to be an Ariane 5 booster. What are the 4 holes for? I don't know. This is probably a test article, which is why it's sitting outside, and those holes are probably something so they could see whatever they were testing. Hey, Pat, what's going on? Any news about Flight 6? Sub-Zero, I still think it's November. I think it's going to happen a lot sooner than we think. I think we're going to see a booster static fire today, too. Could you please explain what's going on in this? Cool shot, Supercraft, though. Elon said to Everyday Astronaut that Pad 1 has an upgrade due after Pad 2 is done. Yeah, Bilo, yeah. That was... So, that's probably where I recalled that information off the top of my head. But if you understand SpaceX's processing flow, once Pad 2 is operational, I would basically... I would change Pad A's OLM to a Pad 2 design. After it's tested, though. You don't want to, the idea is to not have a non-operative pad. So Drummer, please react. This is very good. All right, you're asking me to react to too much stuff. This is a shot from on board the fairing. This is inside of the fairing looking backwards. So you're seeing the re-entry heating happen. I have the coolest intermission screen of any streamer. Thanks, Force. See, the sparks, you're getting some slight ablation of the fairing material. I don't think this happens anymore on the fairings. I mean, it might happen a little bit to an extent, guys, because the fairings get burnt a little bit. So they do ablate to an extent, but yeah. This is a shot on board the fairing, looking back up as the fairing's coming down through reentry. What you're seeing is plasma flow. That's plasma flowing over the fairing and then quickly dissipating. There is some convergence here because the fairing is basically like bowl-shaped, right? If you're looking at it from this angle. So the plasma flows off the back and then it actually kind of rejoins. It kind of, they converge on each other up at the top. That's what this is up here. The two flows from either side of the fairing are rejoining. You get convergent flow, which is super cool. This is really neat. I remember when this footage came out. This is happening basically right now, guys. On the L-167 fairings, what you're seeing is what they're doing. This isn't a live shot, obviously. This is a much older fairing design, but what are the black squares? Insulators, sound insulators. Some payloads require it, Cat. Some of them don't. That's part of the reason why I know this is an older design, because, or it's a fairing that's designed for a more sensitive payload. Could be either one. Sorry, Dean. What comes first? Pad 1 redesign rebuild or pad reconstruction launches from KSC? Ooh. For high delta V launches that the fairing's lost? No. No, Journey. In fact, for high delta V requirements, they're pretty much the only thing that comes back. They got the fairings back from Europa Clipper, dude, which set a record for fastest Falcon 9 ever. That second stage hit 12 kilometers a second on the Transmartian injection burn. Because it's a gravity assist off Mars, right? If I'm remembering correctly. What kind of trajectory would this thing be taking? Similar to Dragon? No, not similar. It's way suborbital, Drummer. The fairings don't really go faster than 5,000-6,000 miles an hour at best. Yeah, they really don't go much faster. Keep in mind, the entire fairing is a gigantic speed break, so it doesn't. Its terminal velocity is super low, so it's basically decelerating pretty much the entire time after it separates from the rocket. In fact, I would probably say that at fairing separation is the fastest that fairing is going. Those fairings are going to go. Yeah, I don't think they accelerate on the way down. I seriously think they make that much drag, maybe a little bit, but it's not as much as you might think. Yeah, Mars, Earth, Mars, Jupiter. Yep. McGregor just did 12 relights again. Crazy. Do you know the weight of a fairing half? Oh, Dean, a fairing probably weighs as much as maybe a smart car, but it's the size of a school bus. Or actually, I mean, you guys want scale. A school bus can fit inside of these things. School bus can fit inside of that. Everyone is posting links. Everyone that has permissions from the mods are posting links, Darth. But you're right. On the Starlink missions, they do not have these insulators on Starlink. Starlink satellites are basically like the Fisher-Price toy of satellites. They're designed to be banged up. Don't worry, you got perms. You can link it up. I'm ready for that ride. Yum Food, if the G-forces weren't like really bad, that'd be pretty cool. Surfing a fairing on plasma, I would like. I'm not going to sit here and pretend like I wouldn't enjoy that. It's just that I'm going to go ahead and guess that this is a pretty rough ride, you know? Convertible spaceship. What do you call the plasma shape? Okay. Hold on. Give me one moment. trying to find a diagram that we can show. Here we go. This is NASA's. This is a NASA picture, so you're good to show it. Here, check this out. All right, you want some definitions about reentry and how plasma flow happens? So the thing that you're seeing, the thing that you're most likely asking about, Chris, is what's called the bow shock. Right there. That reconverging flow that I was talking about with the fairings is called recompression, and that's what's going on right here. You do get flow separation with plasma, but in this particular case, because the fairing is not shaped like an upside-down bowl, the flow separation is happening on the rim of that fairing half right there. See that? Yeah, you're also going to get a shear layer and separation off the heat shield on this. Once again, this separation, the shear layer, and that separation on the fairing, because it's a slightly different shape, are all the same. It's all kind of the same thing. And then you don't have an ablation product contamination. You don't have ablation product contamination as much on the fairings. The ablation product contamination in this are those sparks. Anytime you see reentry heating and you see sparks coming off of stuff during reentry, that's ablation. The sparks are something ablating. In the case of Starship in Flight 5 and Flight 4, you saw a lot of sparks. And then the wing decided to get cut in half by plasma, right? That's because you had plasma burned through between your tile, and it ablated the flap from the inside out. Yeah, the stainless steel became your heat shield. Problem is that that's not what you want your heat shield to be when it's a control surface. You don't want your control surfaces getting just eaten away. Theoretically, could an astronaut ride a fairing half down through reentry? I don't know. It really depends on the G-forces, Ghost One. I mean, I'm going to go ahead and say that that's probably superbly dangerous, but I'm also not going to say that I wouldn't do it. Like, if I knew that it was safe, I'd do that. How crazy would it be to see that with your own eyes? Like, it's, yeah, plausible, I guess. A smart car is 1,500 pounds. Terminal velocity is 200 miles an hour in that weight. Yeah, but aerodynamics will affect your terminal velocity, Dean. If we're talking straight mass under gravity, I mean, yeah, the fairings probably go slower than 200. I know with the parafoil, they touch down very slow. Sign me up in the next Tom Cruise movie. Yeah, just have Tom Cruise do it. It'll be fine. Does reentry plasma emit X-rays or other harmful radiation? I don't know, O-Force. I would say no, but I'm not sure. They had a plan if an astronaut would need to ride down in the shuttle payload bay. That would happen if the payload bay didn't latch, Dwarfman. They would literally have somebody hold the payload bay doors together. That would probably be the closest thing to riding back in a fairing. But also, the shuttle goes way faster than a fairing. Here we go, BA. So EJ's surfing the fairing because he's EJ. What's that supposed to mean? Then how long would you theoretically need to stick out a can of beans to heat it up? Maybe a half second? BA, believe it or not, somebody has done a semi-scientific paper regarding this exact phenomenon. There's a gentleman by the name of Randall Munro. Randall Munro is a scientist at JPL, the Jet Propulsion Laboratory. And he has a book called What If? And What If examined the math of what you need to do to basically cook a steak using reentry. Now, here's the thing. How long would you need to cook something out there? It wouldn't work that way, dude. The reason why is because at this particular point, you're only getting heat, like during reentry. And this is basically the gist of this paper. The math has been done. you're most likely, so like if you had a steak, or you asked how much, if you stick out a can of beans, you stick out a can of beans, it's most likely just going to ablate. It'll just melt. A half second, bye-bye. It would be like it would Thanos itself very fast. A steak, however, interestingly enough, the reason why is because the can, right? You got a can. The can is just going to absorb all that heat super quick and probably cook the beans inside, but the walls of the can are only so thick and it can only take so much heat. The problem is that you're not going to be able to flux the heat through the entire can. So one side of the can is going to basically just melt completely, and then there's nothing left, right? If you had a steak, believe it or not, if you had a steak and you had raw steak and you threw it through re-entry, right? What would happen, believe it or not, is, and once again, there was a paper written about this, and then some guys from England tested it in a hypersonic wind tunnel so the steak would basically pan-sear itself on one side. So if anybody else is pan-seared a steak to, seal all the juices inside. If you like cooking, you know what I'm talking about. It would pan-sear one side initially, and then it would make a nice ablative heat shield. It would just ablate off. There'd be nothing left. Yeah, how thermal flux happens or how heat moves around during reentry is fascinating. It's really interesting stuff. So the steak would pan-sear itself and then basically just ablate off. Once again, the interesting findings from that paper. Once again, Randall Munroe, he has a book called What If, and that's one of he basically chugs the numbers for doing this. He actually did the numbers, and it actually turns out that steak is a great ablative heat shield. Raw steak is a great ablator. It's great. It's really good as a heat shield. It's like in line with pica, with phenolic impregnated carbon ablator, which is strange. Yeah, raw meat actually makes a great heat shield, which is all right. A lot of heat shields are made out of carbon. Steak is carbon to an extent. Like, it is carbon-based. Yes, raw meat makes a great ablator heat shield. Yeah, who knew? Right? Yeah, no, it's very weird. Because it pan-sears one side and then ablates off, it works exactly like a phenolic impregnated carbon ablator or Avcode. It works exactly the same. It's very weird. But yeah, once again, shameless plug for Randall Munroe and What If. Hilarious, dude. It, like, some of the math problems that he kind of chugs the numbers with, really funny, actually. Yeah, once again, somebody actually corroborated his math by putting a piece of meat in a hypersonic wind tunnel. You think I'm kidding? This is a Schlieren image. Basically, yeah, see, it starts, that's what I mean. It starts to pan-sear one side. You get a nice pan-sear going, you seal those juices in, and then it starts to ablate. See what I'm talking about? Pretty crazy, huh? Re-entry heat isn't a convection oven, man, like, it's not, you're getting a lot of heat from one side really fast. Yeah, dude, somebody actually did that. It's really goddamn funny, actually. I'm sorry, that makes me laugh, dude. I never thought I'd be sitting here discussing Schlieren images of Salisbury steak in a hypersonic wind tunnel. It's still funny, dude. I'm sorry, that's pretty good. Imagine the smell. Probably smells great, Rib. It probably smells great, dude. I'm sorry, that's pretty damn funny. Oh, God. What is that video? Well, look. Video 1. A Sainsbury 21-day matured beefsteak in Mach 5 winds. Recording using Schlieren imaging to show the hypersonic shockwave. I'm sorry, it's super goddamn funny. Look. See? Pan-searing, baby. And then it decides to ablate away. So goddamn funny. You know what the fascinating thing about this, right? Like, look at how the steak moves the heat around. Look at how cold it is on one side, and look at how warm it is on the other side. Isn't that weird? Like, dude, it's a great ablator. That's perfect. That's perfect for how you want a thermal ablation heat shield to work. I'm sorry. That's really funny to me, man. Who knew? But yeah, what if, dude? These guys, they're amazing books. Seriously, get them on audiobook or something. It's pretty good. The audiobooks, Remo and I have listened to them on audiobook on long car rides, and Will Wheaton did the narration for the books, which is pretty funny. Oh boy. Air fryer is very misleading, Rivian. An air fryer doesn't actually fry anything. It's just a mini convection oven. That's all it is. It's just a smaller version of the big oven that you put stuff in. Who was that writer? Randall Munroe, Fonzie, is the guy's name. It's a toaster oven with a fan. Yep. Yeah. What If and What If 2. Hilarious. So Randall Munroe, if you've heard that name before, he does XKCD. If you guys know what XKCD is, it's, yeah, quite funny. Dude, yeah, no, hilarious, man. What if is awesome. Another question that was asked was like, what if you took every element on the periodic table and had like a cube of every periodic element and you just stacked them next to each other like bricks? What would happen? Long story short, stuff blows up. Yeah, stuff blows up. He has a YouTube too. Cool. Is it the XKCD guy? Yep. So in other words, Elon needs to strap a side of beef to the flaps. Well, technically, no. You don't want that. We don't want Starship to have an ablative heat shield. We want it to be reusable. Now, think about what I just told you about, like, with how heat gets transferred from, like, steak and ablator heat shields. And now think about how absolutely ridiculous those tiles are on the space shuttle and on Starship. That's what the tiles do. They absorb heat, and they can absorb a crazy amount of heat. That's why the tiles are reusable, right? Because the tiles have, obviously you have your windward surface, right? But on most things, the wind, like you have thermal transfer, and that's called heat flux. Flux is the rate of heat being introduced into an object, right? You have a skin temperature of that object, and then you have the total temperature of the entire object, right? So the tile can absorb a bunch of heat on one side, and it can flux that heat into the rest of the body of the tile. Tiles can absorb an insane amount of heat for the surface area. It's absolutely ridiculous, or for the volume, I should say. It's ridiculous. It's a triumph of not thermodynamics, material science with tiles. Like, even with the shuttle, those are silicate based. Now, SpaceX uses kind of an upgraded version of the silicate based tiles. SpaceX's tiles are unifibrous carbon, so they're like a spider web of carbon almost. They're called tough rock tiles, tough and unifibrous, reinforced, oxidation resistant, corrosion resistant. Tough rock. Really, really interesting stuff. Yeah, how the tiles can basically, they can basically transfer heat like internally at the rate at that heat can be transferred into them. It's super interesting, dude. Tough and unifibrous, reinforced, oxidation resistant, corrosion resistant. That's what it's called. The X-37B uses them. That's correct. Yeah, Rocky. Yeah, absolutely, dude. Another good book of his is Thing Explainer. Complicated stuff in simple words. Yeah, dude, for sure. I mean, all they have to do is use that to cook their food to Mars. Want steak again? Boom, reusable. Yeah, I think, yeah. It's corrosion resistant too. Or, I don't know, maybe I'm thinking of something else, dude. Rod got, like, I don't know how you do it, man. I got a lot, there's a lot of info. I go through a lot of information every day, dude. Yeah, the C is carbon, not corrosion resistant. You're right. I'm thinking of something else. Too many acronyms, man. Hello from Arkansas, Failspace? AR. Arizona or Arkansas? Which AR is it? I forget. So ridiculous. So my ridiculous original KSP space planes that use top-mounted radiators to keep from overheating on reentry would work in real life. No, they wouldn't. The radiators would not be able to... The radiators in Kerbal might be able to do this, but in real life... So, okay, Creation, two things. In real life, if you put a radiator, like from the ISS, on the backside of Starship, it would not be able to flux the heat out. There would be too much heat coming in, too much heat coming out. It's better to tank the heat. You're going to get some natural thermal radiation from things, like stainless, for instance, right? But in the case of Starship, it just straight tanks it. The shuttle did too, for what it's worth. Arkansas, AZ is Arizona. Yeah, I just wanted... I don't know why my brain did that, but anyway. You should get Joey B to cook a plasma steak for you. Yeah. Toughened, unipiece, fibrous, reinforced, oxidation-resistant composite. That's what it is, Rocket. Thank you. Thank you. Just to let you know, Raptor relit 12 times at McGregor on NSF. Yeah, Thor. Yeah. It's pretty cool. I lost my train of thought, sorry. Oh, Creation, the radiators, excuse me, yes. Linus, I have it. Give me a second, it's too much. Too many questions. Only 12? Yeah, I know, right? So, Creation, radiators on the back is not a bad thing to do in KSP, but it doesn't really work too well in real life. It's better to just tank the heat. Like I said, that's what the shuttle did. That's what Starship does. But here's the difference. Interesting thing here. Once again, this is super cool to me. I think this stuff is amazing because if you understand what plasma is and how it works, having a spacecraft kind of just float through it is just ridiculous, and it's frankly nuts that somebody actually thought of this. So the shuttle, like I said, it just tanks the heat. It'll just absorb all of it. But with all the tiles and the aluminum shell of the shuttle, right, the aluminum frame of the shuttle, the tiles will basically absorb most of the heat, and some of that will get conducted through the glue, which the thermal glue that held the tiles on the shuttle basically works like thermal paste, same idea. And the shuttle's chassis, like the frame of the shuttle, will conduct the heat to an extent. The whole shuttle is designed to basically stretch under thermal load, which when you think about it, it's actually crazy that thing comes back in one piece. I get it one time it didn't. That was a different story. Turns out a hole in the wing doesn't work very well. I know someone's thinking that. Don't talk about that. Anyway, but because the shuttle is made out of aluminum versus Starship is made out of stainless, the tiles needed to be a lot thicker. So the tiles ended up being very heavy, even though it's high mass. Starship's tiles are actually super small. The Starship tiles are basically about maybe, 2 inches, maybe. So that's like 20 millimeter, 30 millimeter at best. They're not very thick. The shuttle tiles are this thick. How do I know? Held both of those in my hand. Don't ask how. The shuttle tiles are probably like, I don't know, 80, 90 mil. And here's the other thing about the shuttle. The shuttle tile's thickness changes depending on where you are on the thing. That's why the tiles weren't swappable. You had 30,000 individual tiles, and that made it expensive. Starship uses stainless, and because it's using stainless, and frankly the shape is a little bit less complicated aerodynamically than the space shuttle, you can afford to make a lot more of the same tile over and over and over and over and over again. And the tiles actually are thinner. So not only are these tough rock tiles, they can tank more heat, but they're less mass. And then anything else, so behind that you have like a cilia backer on Starship. That's that white blanket that you see them putting behind the tiles. There's a cilia backer to help distribute the heat. Basically, once again, thermal paste. It works the same idea as thermal paste on your computer. I'm pointing over here like you guys can see my computers that I can see right there. I don't know if you knew that. And Starship, because it's stainless can tank heat very, very well. Very well. So, yeah, complete differences here. But using those upgraded tiles and then a stainless steel chassis is actually super smart. Whoever whispered that sweet nothing into Elon's ear is really, really smart. That was a really good idea. This is neat how good the tile insulates. It's unbelievable what these things can do. Like Rocket Guy, I can't believe somebody actually thought of this. Like, I mean, nothing... 9-pound material. You know, adversity is the best thing to innovate. You know, you needed something that works. Is Tough Rock only U.S. technology? I think it's ITAR protected, but I don't know. I don't know what is and isn't ITAR. Or do I?
After a couple minutes. These things have been in there hours. If you put it in metal, it may,
look at this.
If the metal did not melt,
those are the tiles.
It would conduct the heat and keep the heat for so long that you couldn't get near it, well, you know, within hours.
What the actual frick?
I mean, you can take this off. It dissipates the heat so quickly that you can actually pick these up while they're glowing, molten in the middle.
How hot are they?
Well, they were in the oven at 2,200.
Tough Rock tiles are better than that. Those are silicate-based tiles.
Pick them up and take a picture. Just make sure you don't pick it up on the edges.
Don't touch the sides. You can touch the corners, though. You see how good that thing absorbs the heat? It's absorbing the heat so well. It can move the heat inside of it so well because it's porous. There's more surface area because it's so porous. It's like cork almost, right? So it can move that heat into it really, really well. It moves the heat around inside so freaking well. It could come out of the kiln and you can grab the sides of it because it's equally distributing the heat throughout the volume. That's crazy, dude. Who the hell thought of that? Like, bro, that's one of those ideas where you're just like, how'd you do that? Like, not even mad. You pooped in the fridge and you ate the whole wheel of cheese? How'd you do that? Not even mad. That's amazing. Yeah, sorcery, man. Crazy, right? It's good stuff. Dude, like, this is one of those things where you're like, there's people out there just building stuff like this. Like, man, I gotta get out from behind the damn computer. That's super cool. I like this stuff. I want to be a part of it. Let's do it, you know? Actually, you know I don't speak Spanish. All right, anyway, we're still tagged under L-167 coverage. We should probably stop this VOD and switch over to Satisfactory or something. And the shuttle tiles were made using agile development, a new concept at the time because high amounts of iteration and testing were required. Rocket Guy, you know what's coming. You know that I know that you know what's coming. And I know that you know that I know that you know. You know what I'm going to say. Or do you? I'm going to say, nice, 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 nice. Yeah, you weren't expecting that. Hello. Hello. But also, to be 100% real, I think there's a time and a place for agile development in versus, you know, waterfall development. Waterfall development should be used when what you're making is very, there's not a lot of unknowns, right? So if you know what you're doing, you have experience, that's when you want to do something like that. Agile is for pushing the boundaries when it comes to aerospace. I don't know what people do with software. Sorry, Hazanku. Yeah, we'll change the title up now. Let's I'm gonna stop the this should be labeled not safe for work. Yeah, sorry. I'm gonna stop the YouTube stream, guys, and we'll jump over back into Satisfactory. I had a bad experience, man. Dang it, I'm deaf. We'll get into space news in a couple of hours here. What's the purpose of the skirt? That's the launch stool. Joey. Or Joe. Sorry. That's the launch stool. This gray part doesn't go with it. The rocket is up there, where the silver part is. This just holds it to the pad. Yeah. In software, they are working in agile. Agile development favors software because software software engineering, long story short, it's easy to change code. You can change code really, really fast. So software favors agile development, which... My thing about that is that, like, look, guys, my wife's a software engineer. Brimo's a software engineer. And I hear her meetings when I'm getting ready to go in the morning. I hear the meetings that she has. And, like, I hear people talk about, you know, wanting to do agile and implementing agile when they really don't understand the context of why you should be doing that. Are there any software engineers out there that can corroborate this? Like, I hear a boss is like say, oh, we have to be like this, we have to be like this, we have to be like this, in an application where agile doesn't really make any sense. Am I onto something here, or is it just me looking for a reason to be like, you have no idea what you're talking about? It's a buzzword. It has become a buzzword. Okay. Like, it's like we need to go fast. Like, I think that managers confuse agile because it goes like faster with actually needing to go faster, because they just hear agile is faster and they go, oh, we should do this all the time. Like, not really understanding why you should. Okay, cool. All right. Yeah, because I hear, like, in the morning when I'm making breakfast and stuff, like, I hear Bree in her, what's the meeting that you have right when you get into work? I don't even know what it's called. I don't care. Like, morning meeting stand-up, that's what it's called. I'm listening to these guys. I'm like, dude, that's not what you... Okay. Okay. NSF meat science, yeah, right? Programmers don't even know what they do with software. I don't know. Daily stand-up, Huddle, Davis... Why they gotta come up with all these names? Just, it's the morning meeting to make sure everybody's on the same page. Oh, no, we gotta go to the stand-up. No! Stop do it, dude. That stuff, I don't know about you guys. That stuff drives me up the wall. The buzzwords, I don't know how you do it. I could, dude. I would go bananas. Your daily stand-up would just turn into a rant by me of why we shouldn't call it a daily stand-up, and then I would get canned for not doing anything because I'm so pissed at this. I wouldn't last very long, I'm not gonna lie. It's like the same thing, like, if we should make EJ the NASA administrator. That's not a good idea. That's not a good idea. I wouldn't be able to deal with the bull crap. Like, or even worse, I would be susceptible to it, which just scares the crap out of me. They'd be like, well, you know, it's better if we launch a block of metal rather than the rover. I'd be like, oh yeah, is it? Yeah. Okay. Here, you know what's better for you? If we replace you with a block of metal, you are fired. Bye-bye. I think a block of metal could do your job better. Bye-bye. They'd be like, what? I'd be like, here's your pink slip. Get the frick out of here before I kick you in the face. You know? Like, they'd be like, what? It would be bad. You don't want that. My first work agile meetings with combined QA and engineering, where we all voted on the difficulty of engineering and QA stories. What the frick did, when QA didn't have any idea about the engineering issues and vice, you just end up talking about pudding. You know, Audrey, credit where credit is due. You know, Bill Nelson's doing the best he can with what he's got. Do you know? I can't even imagine the patience that guy must have to deal with what he deals with on a daily basis. Guy has more patience than I do, I'll say that. The concept of stand-up is because it is not supposed to be sit-down meetings. Standing because it should only be 10 to 15 minutes, if that. Yeah, but what's the purpose of the meeting, Rocket Guy, if half the people if the only person paying attention is the boss and the person that's speaking? Everybody else zones out. Don't even pretend like that doesn't happen. I see it. I see it all the time. People shut their webcams off and they go and make coffee. All right, and they have the audio on in the background. You know how I know? It's because they go to it's like, "Oh, EJ, what do you have to say about this?" EJ, can you hear me? EJ, oh yeah. Sorry, I was working. Yeah. Oh yeah. Anyway, yeah. What I'm working on is that. Yeah. Bull crap. You were feeding the cat. Don't tell me that doesn't happen. I see it every day. Why are you booing me? I'm right. Any word on that Boeing satellite that blew up in space? It is still exploded, Chad. Yep. Last time I checked, still blew up. Debris mitigation, I don't know how we're going to do that, but you know. To communicate your daily goals, communicate problems, and theoretically get input from others that may know how to fix the issue. Perfect for an ideal world. Rocket Guy, why are you able to explain all this? Are you one of them? Yeah, pretty much, Audrey. Yeah. Mm-hmm. Satellite was uninsured, too. No refunds. Yeah. Wish I could make that up. Hey, Kippy, what's going on? Yeah, I know, Yarg. Starting to suspect this. Your tax dollars are the insurance. Oof. Rocket leads the meetings. I'm starting to think that, Geeson. Rocket Guy, there's something you're not telling us? Nah, thanks for the insight, dude, but yeah. Because as upper management, I've done deep dives into project management frameworks, and no, my company does not implement or try to implement Scrum as a deep tech company, but it has very useful elements. Yeah, no doubt, dude. I get it. I get it. Do those buzzwords. I just don't like going through the motions, dude. You know what I mean? And maybe that's probably a me thing. It's probably very much a me thing, but also at the same time, I don't think you need to go through the daily motions like on a day-to-day basis for the project. Everybody knows where they're at. Like, or I mean, I guess, or do they? I don't know. Once you heard it once, you just tend to tune it out. Yeah, Joe, it's pretty bad. Fantaro, I've worked as a Scrum Master for about 7 years, so you're deep in this stuff. Oh my goodness. Oh, I'm serious, Tesla. Yeah, Intel SAT 33E was not insured. Whoops. Yeah, Ghost. Yeah, I got you. All right. Yeah, there you go, Ray. Nice. Going through the motions gives management something to do. Rocky Guy, you're a very big proponent of never having a meeting if it can be done via other sources like email or Slack or text or something. Yeah, exactly. Exactly, dude. Yeah. Like dude, I hear it at the company that Brimo works at. They incessantly incessantly like say like you need to have a stand up every day. You need to stand up every day, and it's dude, it's always awkward. It's like, well, because one guy is like, well, good morning, everybody. I'm the boss and I make tons of money. How's everybody doing? It's like, dude, it's like 7 a.m. Just come on. Like this Ned Flanders stuff going on here. I'm like, I'm like by proxy, I'm just like, the problem with stand-ups is that they're really status updates for the boss in disguise. At least that's my experience. Yeah. Okay. Let's restart the VOD. Yeah, this kind of went off the rails a little bit, but then again, you look up off the rails, you'll see my name in the dictionary. Once again, I don't know, if you're on YouTube, I'm gonna stop this one and we'll start up Satisfactory, and we'll go until probably until Booster 13 static fire. Today's gonna be a little bit of a weird schedule, so we'll jump back and forth. Yeah, there you go, Element. Yeah, that's what I'm saying. That's the whole topic of discussion, dude. I have it by proxy with Brimo, and I'm like, oh god, this makes me want to headbutt a brick wall. Rocky, for me, the daily stand-ups are a bit much because all my teams work together anyway and typically know the issues or ways to do things before I get the word was an issue. Agile was supposed to be for empowering your teams, but that has become so backwards for many companies that they say they're agile but aren't. Yeah, dude, it's like full circle, right? Like, okay. So I try to leave my team to do what they know what to do. Yeah, there you go. Yeah, okay, Rock. Yeah, you ain't one of them. Like, you see people throwing around these words, dude, and they have no idea what it means. They just, oh, agile is faster. So it's like, dude, how many people are like that out there? It's probably a lot. It probably doesn't happen as much as you think in aerospace, right? Like, but also, no, it's not. Yeah, right. Okay, I'm gonna shut this VOD off. Let's switch to Satisfactory. Once again, if you're on Twitch, don't go anywhere. I'm just gonna jog the YouTube stream real quick. YouTube, I'll see you in the next one. Be right back. One moment. We'll switch to Satisfactory. Likes is like, I'm glad this nonsense hasn't made it into civil engineering. Yeah, right. All right, I'll see you guys in a second.